Howdy out there. I just pulled this program out of the Fusion 360 CAM samples library. When you install your Fusion, you have all these samples in here. It's a pretty good library of stuff, and these are already pre-programmed. And we're trying to learn 5-axis. So I actually kind of learned a lot of stuff here just by turning these on and knowing what I knew already and trying to figure out the things I didn't know. There's two courses we really love to use. And of course, one is the Autodesk Design Academy and also Titans of CNC. Let me turn on the Academy here. Over. Give me a second. Right here. Okay. You should have a login. I have my login. You get access to the courses. I go into the courses right here. And a lot of us are already familiar with the building blocks, Titan 1 through 10M. And then you get into the Titan rocket, which is 2-axis lathe. So the building block is most of the parts of what we in the industry call 2.5-axis, except for the 9 and the 10 end is getting into full 3-axis of movement. The rocket is 2-axis. The fixturing course is excellent. We want to start making some of that stuff. Then we have the 5-axis course. And the real basic one is the 139M. This is a really good way to just get started. And you can actually do simulations in Mastercam or Fusion 360. You can use the machine simulation to kind of get a real sense of what's going to happen and learn all your setup techniques from any setup video you can find. The 200M is a little bit more advanced, but you learned the 139, you've actually done half the part already. And then you have all these other samples, which are just CAD drawings right now, but I understand Titans are going to update and give you the CAM portion of this very soon. And then we have in our Google Classroom here at school, in our Fusion 360 project area, plus I shouldn't just call it that, I have Mastercam stuff in here. Also, or we go to the Autodesk University, go to the should have called multi-axis number 5. Multi-axis CNC. In this course right here, this is free to, if you have an Autodesk account, and you got all these lessons here. And you don't have to draw the models in there. You're going to import the models. So it's really heavy on the CAM side. All right, let's get back to the Fusion. And this one's called the lower control arm for the Haas UMC 750, the Universal Machining Center. I forget what year the machine came out, like 2012 to 2014, somewhere around there. It was just at the end of the classic control era and then next gen. So there's a version of the classic control of the UMC 750. Now, traditionally, on older cams, on other older machines, when you added a 2-axis table on the machine, you had to find the center of rotation. Like on a 4-axis part, it's probably best to do center of rotation for the part that you're holding. And the same thing with this. This is going to be the rotational axis right here, and then you got tilt axis. And it's going to be either described as A and C or B and C. It depends on which way it's rotating. Now, this one could be called B or A, depending on which orientation you have. So let me just put it on the home view. So this one has a platter, which is the size 750, I believe, is 750 millimeters of the platter. It has I think they call this a rock lock clamping system. So this stays permanently on here, and this can interchange, and you can do quick setups. So this holds 2 parts in soft jaws. So I don't see the material on this side, but it's got two setups. So actually you could do two parts at once, complete parts. And we got soft jaws right here. This is a soft jaw program. You want to see how they do the soft jaws. Okay. Shut all these off. And this has the NC program, which has been out for a while, but see, most people go right to G code, but NC program is right up here. And right here it says out of date. So if you just run it in NC program, you really don't have to go back to here again. All right, let me go to operation 1. I like doing a simulation. And I go right to simulate. And I should get some green material there, but now we got more to look at. I'm going to zoom up a little bit and hit play. So it's typical face milling that you would learn in any other CAM tutorial. And we're doing some roughing here. Let me open some of these up here. I got rough and finish described. And I have it to change colors by operation. And the whole goal is also not to cut into the vice jaw. So if you can learn your Titan 1 to 10M or any other tutorials you're using, you could definitely program all this easily. Let me do a jump ahead here with, now you notice it's tilted, right? This is tilted. When I first saw that, I said, oh, how is it doing that? Now this would be machining that way. Remember the Z-axis is your up and down axis. So this would be the orientation of your machine. It'd either be like this or this, depending on the machine. I believe the 750 tilts like that. Now it's back to the top again. So when you do cam simulation, it's not flipping like it would be in the machine. This is the kind of simulation you're going to get. The part will stay still and the tool will flip. Right. I'm going to pause a second because I'm going to add the new machine simulation in here. Okay, so I changed the machine to the simulation machine. And actually I got some warnings right off the bat here. And actually the machine settings actually are pretty specific. Spindle speed is larger than supported for this machine. So a UMC 750 basic machine is 8100 RPM and the SS model is, I think, 10 to 12,000. So that's just a warning to let you know that this is programmed for a higher RPM. Let's go back to simulate. And now we have a whole machine. I'm going to show the whole machine. This is the whole machine right there with the base and everything. Now the plat is not in the exact spot because when you bring in the model, it's trying to align that way. But you can actually move this around. I'm trying to figure out how to do it live with the machine there. But if I know the thickness of this platter, this is what this new part position is here. So if I say that's 1 inch tall, move it down 1 inch. Okay, then when I turn on simulate again, click back to the machine. So I actually kind of buried the platter in there, kind of aligned with it. So it's the best I can do. So probably the best with this is actually to remove the platter for the simulation purposes. But here we are. And this is the whole machine right there. This would be the front of the machine. This is the tilting axis, so that would be B axis, B. And I understand that the B axis can rotate counterclockwise 120 degrees, but clockwise only goes 35 degrees. And I believe why they did that is when this thing swings up, this side is the tool changer side. There was an issue with tools crashing into. You have a long tool and this thing hanging way up. You could possibly crash. It's something you always want to be aware about on any setup or machine. All right, let me shut off the outside, just show the base. So this, everything with the spindle loaded material there, just like you were looking inside the machine. And now we're going to hit play. Now this is going to orient just like it would in a real machine. So this is all B is facing up, so this is B0, and the C is the rotational axis, so we would probably set that as C0 or the vice aligned with X. And let me just jump ahead by operation. Next operation, and flip. All right, so now it's flipped. So this would be B90, but C is still at 0. Machine that side. All right, but the same stuff you've been learning on all the other previous projects. Now we're back to machining the top. This would be B0 position. So in this particular part, just looking at it, it looks like, unless I'm missing something, it only needed to be orientated once. Because everything else was accessible from up here. Oh, I'm sorry, I missed that one. Let me go to the end. And also, oh no, this is tilted at another angle. Sorry. So this would also be B90, but the C is rotated. The C is rotated. So if I move it to this orientation, let me move this out of the way. Looking this way, the C is look like, I don't know how many degrees it's rotated. I'm just looking at it. It looks kind of like 15 degrees, I'm guessing. So this is your front view, like front of the machine view. All right. So this round part right here is the center of the B axis. And the center of the platter is the C axis. So when you tilt, and then you get back to how you set these up and where do you put the coordinates. So I'm going to go back to the beginning and get out of simulation here. All right. Off, close. So they have the center of this vise as X, Y, and Z0. So you go to set up the machine, you could actually set this up without the material, as long as the material is correct sized. And this would be your X, Y, Z0. And just leave it as one coordinate. Now, if we do operation 2, and that's the same setup, same coordinate system. Now, you could separate them and give them 2 different offsets. If you were having difficulty getting a fine, like the overall thickness was coming out like 1 or 2 thousandths short, so you could probably make that a separate offset with all the same exact numbers and a slight adjustment maybe on the z-axis. The kicker comes in is when this rotates, your x, y, and z is in a different place. Now, if you're using this coordinate, it's kind of like a whole different coordinate system. So the older 5 axes would program it. You put your x, y, z on the center of rotation. So once it's tilted, it's always in the right place. The only problem is if you don't set it up exactly like this, like if this is not on center and this is a different height, everything's going to be off. So the Haas has something called a new command called the G254 command, which activates dynamic work offset. So once you get this coordinate set, and you'd want it to be so the platter is parallel to the table, which would be the B0 position, and orient the C platter to be rotated in the correct direction. and then you get your coordinate, XYZ coordinate, and it knows where the center is. So as it rotates, it's going to keep on doing math calculations to get you tilted correctly. So it's actually a great upgrade because now it doesn't really depend where you put this on the platter. It's going to self-calculate its way there. All right, so if I want to do both operations at once, I could click both of them for simulation purposes, or you can go up in the NC program, hit edit. Up here we have operations. So if you don't select soft jaws, but I got two operations, all of them right. This is like if I was to post them, as far as selecting them for simulation, I go and select op1 and op2. Now they're both active. And I'll go to simulate. It takes a minute. Machine up. Machine on. Wait a minute, do I have that on? Oh, I think on this operation, inflicting. Yeah, this one is UMC 750. This one I got to update. Oh, simulation file. Go in here, hit edit. Oh, no. Edit this one. We'll compare it. It's setup. Soft draw. We don't want that. Edit. Get machine selected. This is second operation. We want to edit that one and also select that one so they're both in play. Select. Okay. Now I'm going to click on this one and control click and then hit simulate. It says multiple work offsets. Yes, that's fine. And now we get the machine again. Press play. I'm going to go operation by operation. Tilt, back, machine, X1, X1. Tilted this way. Next operation. Also, you got to be careful of heights, extensions. Make sure you got enough clearance. Back to the top. So this is on the still in first operation. First operation. Now it's on the second side. Let's show the material though. So this is face milling the back off. Let me just open that. And it looks like it's got a lot of stuff there also. So this two operations is a little more complex. Most people are going to be doing one operation with like a dovetail cutter or a self-centering vise to grip the bottom, and then you can figure out how to do the second operation. All right. That's tilted in that direction to get that little angle. So let's go play by play here. I'm going to shut off the simulation. You know, it's getting a little bit long. I got adaptive from the top. Let me turn that on. Adaptive, drill, roughing from the side. Let's go edit this one. What's the difference here? Yeah, we got 12,000 RPM. Yep, that's why we got rest machine. And now we have tool orientation. So let me move my E person here. Tool orientation. So XYZ was the middle, still the middle of that hole. But we want to machine, either we're machining this or that. Just set around right there. So as far as, looks like they're trying to machine that. So they got it twisted at 90 degrees. So how do they get that orientation? Edit, tab. Right here it says select Z-axis face. So in this case, they selected the side of the vise just to get the orientation correct. But adaptive identifies the model. So on your heights, but you got to control how far down it goes. It's going to try to do the whole model. So they picked something like a line there or something like that to control how far down to go. Because if we didn't have that, I'll leave that alone. I'm just going to clean that off. Go to like model bottom. It's going to try to machine the whole thing. Let me see if it can do it. Identify anything. Yeah, it's actually trying to machine around there, but you notice it's going to go right through the vise. Now, if you get some of your settings in here, like, let's see, catch up here, edit. And when you go to simulate here, simulate, and you turn on collision. Oops, I still got the machine on. Okay. Over here, stop on collision and close. And we'll go back to run this puppy again. All right, we're gonna go simulate. Takes a while for it to come in. Step 1. Oh, still calculating. Still calculating. 1, 2. Tilted. Just press play. It's working its way down. What we're trying to do is rough this to size. Are we getting... Usually this turns red, but it's stopped. And because we have selected, we got the model selected. So if you, in your setup, if you select these as fixture, and so this is identified, it cannot go any further. So if we go back to adaptive, edit, flip this around again, that would be side. And your heights, oh, sorry, I'm on the wrong end. No, I am on the right end. I'm going to say I want to, let me pick something like, maybe like, I can get down about here. I already did this curve. I really don't need that. I can use that one as my bar. No arc, no additional arc. And that should be able to navigate that without hitting anything. And there's really no need to go any lower than that. So you take what you know in the 3-axis world, turn on tool orientation, and then start getting orientated and learning how to use 2D and adaptive and being able to control it and not try to go everywhere that's possible. Because on the first operation, we usually just go model bottom. It does everything. Works great. Now we need to limit it. So these are little tricks you got to use on that. Okay, this is a very long video, so I'm going to cut it short. Stop here. Talk to you later.